and that your conversations during the networking session were insightful and inspiring. Now it's time to shift our focus to a core strength of civil engineering at IIT Madras: research, innovation, and academic mentorship. This session brings together professors from each division of civil engineering. They'll walk us through how their field has evolved over the years, the cutting-edge research happening right now, and the opportunities available for students, from workshops and internships to live projects and lab work. If you have ever wondered what it's like to do research at IITM or how to get started, this is the perfect session for you. We'll now begin with the first speaker, Professor Atul Narayan from Transportation Engineering. Let's welcome.
Largely done. Have you ever gone through a course on transportation? You are yet to do. How many are yet to have a course on transportation? Okay, so for the benefit of everybody here, so what do you think transportation engineering is about? Is it about designing vehicles? Just roads, is it? Is that what it is? So, maybe, is it just roads, railways, traffic, ships, ship pathway, what? Is that what it is? Traffic management as well, right? So, it's actually a diverse field. It encompasses everything that has to do with connecting people in terms of, transporting either people or goods from one place to another, right? So, if you look at our division, in civil engineering department, at least in this campus, right, we have 6 different divisions. Out of that, we have the transportation engineering division here. Can you go to the next slide, please?
ఇప్పుడు చూసి పెట్టిన మళ్ళీ బ్యాక్ చేసి తీసాను వీడియో రికార్డింగ్లో పెట్టా.
So, our transportation engineering division, we have typically 2 streams. We have the transportation systems engineering stream and the payment engineering stream. So we have 2 different streams like this, and we have 7 faculty members. These are the faculty members in the transportation systems engineering side. We have Professor Bhargava and Professor Lalita. They specifically work on traffic flow theory and related areas, intelligent transportation systems, bringing technology into the development of traffic. Professor Karthik, he works on these as well as travel demand modeling, so trying to find out where the traffic is going to come, where are people going to go, right? That's so where do they come from, where do they want to go. Only if we know these, we'll be able to plan ahead our future networks, our future roads between 2 different places, right? So for that, we need to do travel demand modeling. And Dr. Anmol is a new addition to our group. So he works on sustainable transportation, freight transportation, logistics within the city, these kinds of topics. In the payment engineering side, you have me. I work on material characterization, bituminous materials. Now I've started granular materials a bit. So how to model them, how to analyze the way they would work in a payment. Professor Murli Krishnan works on again bituminous materials, on recycled bituminous materials, different ways of rejuvenations, right? So cold mixtures, cold recycled mixtures, hot recycled mixtures, these kind of things. Dr. Sridhar works on the cement concrete side of payments mainly, but he's also the guy for recycled aggregates. Different types of recycled aggregates, like aggregates coming from roads loads, existing loads, when you pulverize them, mill them, pulverize them, and then use it again. Those are called reclaimed asphalt pavement. Have you heard of these? Reclaimed asphalt pavement? No, they are the most recycled material in terms of both volume as well as mass. Right? This is the most recycled material in the world. You may have seen these kinds of roads, in urban areas, where suddenly a machine would have come, scraped the top layer, and then a few days later you have another layer on top. Have you seen this? Have you witnessed this? So where does the scraped layer go? Where do you think it goes? They get recycled into the layer they are laying again. So this way we save on aggregates, we save on bitumen, right? So Dr. Surender works on that, on how to use recycled aggregates in cement concrete pavement, right? These kinds of reclaimed asphalt pavement, construction demolition waste, bricks, coir, how to use them. These are Dr. Surender's. So, we would love to show you around. We have 6 different laboratories here. We have the pavement engineering lab, we have the driver simulator lab, we have the recycled aggregates lab, connected vehicles lab, asphalt lab, and traffic and ITS lab. I think we have the largest lab in India in an academic environment for both pavement and traffic related research. You go by some of the facilities that we have in these labs. So in the pavement engineering lab, we have 3 different ways of compacting the material. Bituminous mixture, the most important thing is how you compact it, right? So we have 3 different ways of compacting it, different ways of mixing it, and these are, I hope this works. So these are advanced ways of testing. So the EN standard tester and AM asphalt mixture performance tester, they are advanced equipment. Each of them costs around a crore. These are for advanced characterization. We also have the wet field tester. You see a wheel here that goes back and forth on a road to simulate rutting, those kind of things. We also have a virgin laboratory foaming plant. So it actually foams bitumen so that bitumen can coat aggregates better. See, so these are part of new technology that we are implementing in pavement engineering. In terms of pavement analysis, evaluating existing pavement, we have pave tracker, rondas, and dynamic current penetrometer, these kind of devices. So, these are the facilities in our asphalt lab. Of course, we also have penetrometer, ductilometer, softening point, those kinds of devices. These are standard ones, but in addition to that, we also have the rolling thin film oven. This is for short-term aging the binder. We have the pressure aging vessel for long-term aging. We have this, the NCAT oven. That's for finding out how much binder people have actually put in the mixture, right? So, because bitumen is more expensive, so if the quality control is not done properly, there is a tendency that contractors may reduce the amount of bitumen that is put on mixtures. So in our quality control check, we want to find out exactly how much bitumen goes into the mixture. So we have both the rotor evaporator and the Troxler and caravan can be used for that. We also have an emulsion mill to make bitumen emulsion, right? So how is bituminous mixture usually made? That's how bitumen is made. Then we mix it with aggregates, lay it on road and then compact it with rollers and so on, right? So how do you make this mixture? Heating, right? So you heat bitumen to how much? Do you know what temperature we heat it to? Huh? It goes up to 150. In fact, with polymer modified bitumen, it can be as high as 170. Right? We also need to heat aggregates to a temperature because that's when, otherwise, aggregates will absorb heat from bitumen. The whole mixture will become cold. We won't be able to compact, right? So how can we avoid this kind of heating? Heating requires a lot of energy, right? Huh?
Like overheating.
No, that also consumes a lot of energy, right? One way is to make an emulsion. So you take bitumen, mix it with water and shear it at a very high rate. You use a little bit of surfactant. Surfactant is something like a soap, right? So it kind of makes an emulsion of bitumen and water. Now you have something that is liquid even at room temperature. Right? Now you mix that with aggregates, lay it, water will evaporate, bitumen will remain, you have your road. Right? Saving so much of energy in that process. Right? So that is one technology, and I think we are one of the very few labs we have who has an emulsion mill to make our own emulsion here. We also have Brookfield viscometers, standard equipment, but we also have two dynamic shear rheometers. One for very advanced, so this one costs around 30 lakhs. The 302, the 702 is close to 1 crore. These are some of the advanced equipment we have. If you haven't visited this yet, you should visit this one. This is our driver simulator lab. We have both a car simulator. You see, this is a car simulator. This is your bike simulator. The bike simulator comes with a VR headset. The car simulator is a fully functional, 6-dimensional, 6 degrees of freedom simulator. So if you go, let's say, over a speed breaker, you will actually feel the bump of a speed breaker. If you go over a pothole, it will shake accordingly, right? So it has the exact way to simulate how a driver will experience driving on a road, so that we can study how a driver actually drives over a vehicle. In what way they slow down, in what way they will accelerate if there is a lot of space available in front of them, right? So we have a driver simulator lab for that. We have our ITS lab as well. So you know IIT Madras, we have 4 roads around it, right? So we have the Rajiv Gandhi IT Expressway, we have the Taramani Link Road, and we have the Velachery Main Road. I don't know what it is called exactly. And then on this side we have the Sardar Patel Road. We have sensors all over this road. And in fact, in addition, we have sensors in different parts of Chennai as well. And we have around 400 GPS devices in different buses in the Chennai transportation system. So we are monitoring, how buses behave in our traffic, right? At what time they can arrive. Let's say they start at 4 o'clock from a place, at what time they can arrive. So all these things we can study using our ITS laboratory in our campus. We also have a recycled aggregates lab. We have, I cannot think of another institute that has these crushers. We have our own jaw crusher, our own impact crusher to crush aggregates. Whether it's recycled aggregates, whether it's demolition waste or regular aggregates, to crush them, getting them to the properties that we want them to have. We also have the aggregate imaging system to, that's 30 lakh, 40 lakh equipment. That's for imaging and finding out shape properties of aggregates, texture properties and things like that. We have a compactor, we have a helium pictometer, and so many other advanced characterization equipment. So we work with several ministries. Ministry of Science and Technology is the foremost of them. Of course, we also work closely with Ministry of Electronics and Information Technology, MeitY as they call it. Housing and Urban Affairs, Ministry of Road Transport and Highways. We also work with the National High Speed Railway. We have collaborations, or sponsored projects from the UK India Education and Research Initiative, Indo-German Science and Technology Center, Kerala Highway Research Center, Bureau of Indian Standards, and COIAB. So these are research scholars, some of them, at least this is a picture that we took from when the TR division turned 50 years. right? So we had our golden jubilee kind of thing. Right now we have our 29 PhD students, around 35 masters, MTech and MS students. So some of the solutions developed include this. How about a bus signal priority system, right? Signal system that gives priority to buses. So we have developed such a solution for Indian conditions. We have onboard driver assistance and warning systems. So public transit route guidance systems we have applied. These are apps that we have developed for this purpose. So we also have developed a departure time plan. So at what time should you depart, so that you can arrive at a place at a time that you want to arrive. Of course, we were foremost in developing the IS 73 specifications for unmodified binders. And we also developed this unique material for the high-speed railway system. So in this system, right? So this is called as the track slab system that's used in our, Mumbai Ahmedabad has the Shinkansen bullet train. It is coming up, right? So it has what is called as a slab track system. So you have a track slab at the top. You have a concrete bed or a viaduct at the bottom. So in between these two, we want a cushioning layer, right? If you look at our Chennai Metro or any other metro, you will just see a cement mortar, right? But this one, instead, it's actually a cement asphalt mortar. It has both cement and bitumen put together along with sand and other things, so that it can act as a cushioning layer. So we developed one formulation for our high-speed railway system. We also developed a urban freight consolidation app for, it's a consolidator. It tries to plan how freight transportation can be carried out within a city. So, with our recycled aggregates lab, we have our India's first testbed facility dedicated to recycled aggregates. There's one stat that is wrong. So we have now reduced to 7 faculty members from 9 faculty members, because one faculty retired and another switched to data sciences department. But we do have 64 postgraduate students. We are if you look at 10 years from 2023, we have 250 publications in that time. 86% were in the top journals. We had 30 crores of research funding during that time, and we have developed 20 copyrights and patents. I think the transportation engineering division has the most number of patents in the civil engineering department. With that, I'll end my thing. So there are always requirements in terms of project staff, PhD students to work on different projects. So I myself, I have a DST project, a project sponsored by the Department of Science and Technology, where I'm looking for a project staff. And similarly, if you look at every other faculty member, they are always looking for project staff. They are always looking for students. We are always working on something interesting. So feel free to contact us anytime. We can always give you more information on what we are working on, and where you would be able to help us. Right? So thanks.
Thank you, sir, for that insightful talk. Up next, we have Professor Ramesh Kannan, who will be sharing research highlights and student opportunities in geotechnical engineering. Let's welcome, sir.
So, how many of you are from IIT, outside IIT? How many of them are outside IIT? Good, most of them. How many of them are from Chennai or outside? How many of them are from Chennai? But most of them are outside Chennai? Good, you came all the way here, huh? Good. A lot of people from Bangalore. So yeah, so my presentation will be slightly different from what Atul has given. I'll just talk more on what I do and what are the internship and other opportunities you will be having. And I'll be discussing more on geotechnical engineering. Probably I should not bore you. I know a lot of students I think they had a good lunch and they're drowsy right now. Some of them are actually closing their eyes. Hopefully you can just go back and sleep. Okay. Most of them have taken geotechnical engineering, soil mechanics, year first, second year, third year. Do you like that subject or it's just boring? Good. Why do you like this subject? It's all about earth science. So you like earth. Good. Okay, so people like earth because, again, as you say, soil is the second most found natural material in the world, and it's very complex. We study the soil behavior, properties, and its uses in many applications over the period of time. Other materials are mostly engineered. For example, concrete and other things are engineered materials, steel, whereas soil is a natural material which you all know. It's highly complex. See, it's very hard to understand anything that is natural. If you engineer, you actually fine-tune and try to design it based on the need, what your requirement is on. Whereas if it is a natural material, it's extremely complex. Okay, so why, before introducing my background and other things, I'll just say why soil is extremely complex. So you build this building on a soil, so it has to withstand the entire load that is coming on from the building to the substructure. So soil withstands heavy load. At the same time, it flows like a fluid. As you can see in a lot of landslides, it flows like a fluid, so it doesn't have any strength to it, right? So that's the whole problem with soil. It can act as a solid at some conditions, it can act as a fluid in some other conditions. So it's one of the most challenging material to assess because we don't know how it behaves at different scenarios, right? So this is extremely complex to model, and that's interesting, and we try to get a lot of solutions on these geotechnical engineering problems, right? So before going into what I do and what are the kind of research we do at IIT Madras, I'll just give a brief background of who I am and what I'm doing currently. So again, the CEA organizers asked me to give a brief glimpse of what I do. So again, this is my academic journey. I'll just briefly tell a few slides on my academic journey. So I was like you 15 years back sitting and then just dreaming what to do, what's next in my life, right? So no idea, probably maybe I wanted to go into industry or go into research, no idea. So I was just trying, but the only interest I had is to learn more stuff, and which is what I've been doing it till now and I'll be doing forever. There are a lot of opportunities, but people don't find out. But once you get some opportunity, try to put your 100% effort there. So I did BTech here, didn't know what to do. So in fact, I worked for some time. I felt the work is not very satisfactory. Yeah, getting money, it's okay, but it's not very satisfying. So I thought, okay, I don't know much of stuff, so probably I'll try to do masters or higher studies to understand a little bit more. After masters, still I felt maybe I'm still not good enough in this subject. So the motivation is, okay, I need to understand more. I'm not happy with whatever I understood, and that's what pushed me to do more and more research. I was inclined to do some sort of research over a period of time, which became exciting because I'm trying to learn something new things day in and day after, right? So over the period of time, gained experience, a lot of things I learned, a lot of opportunities. Opportunities are there, but you have to grab it and make use of it. That is one thing I learned over the period of time. Right? So, this is a brief. Okay, so that's my academic journey. It's not to show what I did over the period of time, but I was in a confused state, as many of you right now in your undergrad. But you have to start thinking what you need to do next and start trying to pursue on that, because as you have a little bit clear idea, it will help you to just choose what you want next, and that will actually push you. Right? Try to plan ahead. Probably, yeah, I'm in the same situation, but probably you will. Since you're attending all these summits, probably you'll get some clarity on what you want to do next. We'll discuss about the job opportunities and research opportunities later. But coming to the research journey, like during my masters, it was very interesting. Everybody think soil mechanics is about building buildings, right? Right? You just build buildings on soil. You have to design foundations. You have to build retaining structures, slopes. This is what people are always exposed to. Right? But once I got my master's degree and then went to IIT Delhi, I was just traveling on the train and then I found a lot of tunnels over there. It was interesting. I thought, is it a part of geotechnical engineering? That was the confusion I had at the time. But after going to Delhi, I took a course where I studied extensively on how to drill tunnels and how it is stable. Later, during my master's project, I was trying to design something underground nuclear dumping or nuclear waste repositories. For example, you know there are a lot of nuclear power plants in India, right? So it generates lots of waste, right? It needs to be stored because you know its half-life period is about 150, 200 years. The heat has to dissipate. The nuclear, the uranium and other components is extremely harmful. So you need to safely dump the waste. People generally try to dump it underground, which is the safest place. Again, you need to select a site where you need to dump, and you build a lot of. If you see there, there are a lot of. So there are a lot of tunnels, caverns that needs to be built. You store those probably like 500 to 1 kilometer below the Earth's surface. So you need to drill the tunnels, and you need to build caverns. You need to dump the waste so that it doesn't go out and contaminate the soil around. Right, so that was my first research exposure in Delhi. So it was interesting. It's slightly off from what you generally do as a geotechnical engineer in designing foundations and retaining walls. Then I did something on understanding the mechanics of soils during my PhD, and then over postdoc, I studied extensively on hydraulic fracturing. So you frac the soil. Why you need to frac the soil? You need to extract oil and gas. Right, so energy is one of the most important aspects in today's life because any country's economy is generally dependent on the energy you have, right? We still try to export or import oil and gas from outside the country, but we also have a lot of resources which we need to tap, right? So, how to tap? You just drill a bore well, dig a tunnel or bore well, take it to the reservoir where there is oil and gas, try to frac it. Once you fracture the soil or the rock, try to extract the oil and then take it to the top surface and then try to process it. Right? So how you do this process, it's extremely challenging because you need fracture to be propagating in particular direction to extract oil. So if you're trying to fracture and the fracture actually goes in some other direction, then it's like the amount of money you spend on fracturing is extremely high. Right? This is one of the sectors where the amount of money you can get is much, much higher. I'll discuss about that later. So this hydraulic fracturing is another interesting area which I worked on, and we also have a lot of gas, natural gas that is around. Probably you know there are a lot of natural gas reservoirs even in India which they try to extract, geothermal reservoirs. So from the ground surface you try to extract the gas or Geothermal, have you heard about geothermal reservoirs? You know what is geothermal reservoirs? So you generate electricity or energy through the heat that is inside the Earth's surface. As you go down a little bit deeper and deeper, the temperature is high, right? So you go to some places in North India, you will get some natural hot springs, right? So those high temperature fluids can be used to generate electricity, right? So you drill bore wells, pump fluids, extract the heat. That heat can be used to generate electricity. So this is again a sort of energy extraction that's probably followed extensively in Europe, but in India it's just developing, right? That's one area. The other area is natural gas extraction. We have a lot of gas reservoirs in Krishna Godavari Basin. In Andhra, we have Kerala Konkan Basin. Those basins has a lot of gas entrapped. So once you start extracting this gas, the land will subside, right? So once land subsides, there will be underwater landslides. There will be a lot of other problems, right? So how to mitigate it? How to extract the gas without any subsurface landslides and other things? So we need to understand the mechanics of like when there is an extraction that is happening, how the soil or subsurface materials behave is another interesting aspect that you can study. Right? So these are not a conventional geotechnical engineering, but people do it. I think this is another challenging area which a lot of people ignore, but this is another challenging area. The other things which I was doing after coming IIT Madras is on the dam safety. There are lots of dams in India, and you need to make sure that these dams are safe, especially because of the earthquakes that occur at even now and then. So it has to be safer. And also there is something related to 3D printing of soils, which, because you all know IIT Madras is known for 3D printing of concrete structures, right? So concrete, as you also know that this is extremely energy intensive, right? The amount of heat that generates is very high, and then sustainability point of view, it's like too much amount of cement is not always good. So people are trying to get new materials which are sustainable. What I was thinking is like, or a group of colleagues was thinking to use soil, because in the olden days people construct houses with mud, right? It used to stand for several years. If you go across the roads, there are some termite mounds, right? You know termite mounds outside? Like, yeah, there is something, I think if the termites exit, snakes will go and stay inside those mounds, usually, right? If you observe those mounds, stand for 12-15 years without any, even if it rains, if it pours, nothing happens. So when the termites are able to build such a structure which can stand without, there's nothing in that. It's just soil, and probably the termite is spitting its own saliva. So it's just a mixture of termite saliva and soil. So if you just mix it, you can, and it is building and which is withstanding the intense rain. So why don't we use it, those sort of techniques to build our house, right? Mud house. Probably we are not going for high-rise buildings. Obviously the strength is low, and probably we'll try to get some mixtures which is good in taking the strength. Right? So how do I do this? We do a lot of experiments in the lab. We do numerical simulations. So this is just a lot of things we do in the lab. We do the microstructural characterization, how individual particles behave when there is some deformation or load is applied. I think Professor Atul was saying something about granular materials. We also work on granular materials, its behavior, and how it behaves under different boundary conditions. For example, when you're extracting gas, when the fluid is going inside, when there is dam, when there is landslide, how the soil behaves. We develop a lot of computational tools. We also have laboratory facilities which we use to understand the material response. Atul. Right, so again, geotechnical engineering is not, as I said, it's not just building foundations and slopes or pavements. It's more than that. It's like first you try to understand the behavior of soils, right? And also the other aspects of geotechnical engineering is earthquake geotechnical engineering, where, see, as I said, the complex property of soil is it behaves like a fluid under certain conditions, right? Probably when there is a severe earthquake, because of the vibrations, the pore pressure, I don't know how many of you are aware of pore pressure, so soil has lots of voids. In the voids there will be water, and if there is a sudden shaking that happens because of earthquake, these water which is in the voids tries to push the particles apart, then it starts flowing like a fluid, right? So when there is an earthquake, usually you will see a lot of liquefaction that happens. Even though the structure is extremely stable, still if you see, this is a classical failure which you saw in Gujarat earthquake that happened in India some time back. So the structure is stable, but the foundation is liquefied. So the entire structure actually tilted and collapsed, right? There is not much of a breakage or anything that happened in the structure, but the entire foundation failed. It's purely because of liquefaction, right? So that's another area of study that we carry out in IIT Madras on how to understand the behavior of soils during dynamic actions. The other interesting area is geo-environmental engineering, where you dump a lot of waste, right? So those waste, once it goes into the soil, it contaminates the soil, right? So we dump everything on soil. So the soil needs to be properly done or properly built so that it doesn't leak. The leachate that is getting developed doesn't reach and contaminate the good water that is present. Right, so that's another area of geo-environmental engineering. The deep geological engineering is what I've been discussing in the previous slide. You extract energy, you dump the waste several meters below. So these are some of the areas of research. Some of the key centers at IIT Madras, we have the Center for Subsurface Mechanics and Geoenergy, where we deal a lot of things about the fracturing, hydraulic fracturing, gas extraction. So anything related to energy, we do a lot of research in this area. We also is one of the nodal institute. Recently we got a grant from Ministry of Earth Sciences. We are a nodal institute to develop liquefaction susceptibility map. Because like you have earthquake maps, right? You have the most different regions of map, right? So India is divided into different zones based on the severity of the earthquake. So similar to that, we wanted to develop a map on liquefaction. So which are the regions that is highly prone for liquefaction. That's one of the projects that we recently got, and it's one of the prestigious projects. And we also are an institute which assess the dam safety, and we have so again, dam is a structure where a lot of people are involved, not only geotechnical engineer. Geotechnical engineer is just help in designing the embankment, but you also need help from water resources, because you need to quantify how much flood that is going to come, right? So you need water resources specialists, hydrology specialists, geotechnical engineers, and also seismic engineers or seismic earthquake engineers to assess the dam safety, right? So we have faculties who are working in this area. We come together and then try to address the dam safety issue. We also have a center of excellence on coir, so where we use natural materials for pavements, right? So generally for highways, we used to put some synthetic geosynthetics, it's called geosynthetics, in order to make sure that this road doesn't fail. Instead of geosynthetics, we can also use some sustainable material like coir for the construction of road as well as embankment. So which is good. And with respect to the skill development, I think you all know there are a lot of online programs like NPTEL, MOOC, and so you can just go there, learn stuff. In addition to your bookish courses, you can also go through and read the courses which you are interested in. And also you can actually come to IIT Madras as an intern and try to explore the various research facilities we have. We have, as Professor Atul was saying, we also have a lot of state-of-the-art facilities. We have high temperature gas-controlled triaxial apparatus. We have a physical model setup. We have a shake table. We have a lot of apparatus or equipment which is probably one of the equipment which you can see in India, right? So We have state-of-art equipments all around. We also have a lot of, we are developing a lot of computational facilities. So we have computers with about 1,000 cores. So we have clusters with 1,000 cores. So you have a lot of data you can just run and get a lot of results. We are trying to add more cores. We have CPU as well as GPU cores, which can be used to run and get more analysis done. Right, so you can make use of all these facilities. Yeah. So again, with respect to this is one of the things which the CEA organizer said. Put a slide on industries, research, and industrial opportunities. So, okay, industries. So there are a lot of, again, in soil or geotechnical engineers, we look for some industrial opportunities. Of course, construction industry is one such industry where you can approach. There are other design firms where the knowledge you gain, you try to go and design buildings or foundations and all this stuff. There are other oil and gas companies, offshore geotechnical companies, which requires geotechnical engineers, right? So, oil and gas sectors is, as I said, is one of the highly paid sectors. So, people are just generally being worried about my package is generally less compared to my friends in computer science, right? So, it's a common thing that you always discuss, right? So, in this scenario, like again, this is commonly happening, but again, in oil and gas or offshore geotechnical area, if you want to go and work in those areas, with those sectors, they generally pay much more than what you generally get in IT sectors. You don't know about that, but try to explore those areas which pay a lot, right? So that's industry people can get more packages. You can try, and offshore wind, offshore geotechnics in the sense they're going to construct a lot of offshore wind farms because we are going into renewable energies. So there will be a lot of wind farms that will be coming in the coast, east coast or west coast. There will be a lot of wind farms they're going to install in offshore environment. So they'll be looking for offshore geotechnical engineers. So there will be a lot of opportunities now, especially since we are trying to move towards renewable energy as well as unconventional energy sector, energy-related areas. R&D sectors, again, you know, CSIR labs, public sectors, ONGCs, IITs, IICs. Wherever there is a research lab, you can approach and then try to ask for internships. There are a lot of exchange programs that are there between different institutes in India as well as IITs or other institutes in India and abroad. So if you are part of a master's program or PhD program, you can actually go and visit one of the international universities or agencies or centers, visit there, learn what they're doing and then come back. So we have other exchange opportunities. We also have fellowships for master's and PhD students. Of course, there is PMR 2.0 is coming, where I think the PhD people who are interested in doing PhD have to compete and get this fellowship, and this fellowship will pay much more than what generally you get if you join an industry, right? So that will also be motivating for you to at least pursue PhD, right? So I get a lot of, so this is my last slide, I'll just finish. So I get a lot of emails, or a lot of faculties here get a lot of emails on internship opportunities. See, when you try to write to a faculty about internship, don't write generic emails. Don't copy all the faculties in the division and then just send one email saying that I'm interested, can I come in? It shows that you're not interested. You're just sending bulk emails, let's see if somebody responds. That's not how you want to write an email. So how you write an email actually will make the person to respond to the email, right? So you spend time, focus on where you want, like which area you want to work on. Try to emphasize on how to structure your email and what you are interested in. Probably certain points which, when as a faculty, when I'm reading the email, I have to find out that okay, this guy is actually interested. So that if it counts, then probably you will respond. Or else like it's generic email if you write, not many people, because we are getting so many emails, right? So you have to attract the faculty, whether you're really keen on coming as an intern and then exploring. Again, coming as an intern, after coming back, coming to IIT, You need to stay long, little bit longer. It's always good. If you stay for 15 days, there's not much you can do as an internship if you're coming as an intern. Right? Try to stay longer. I know you have concerns with your academics or the post-institute or the institute where you're studying, but try to get longer, come for a longer duration. Of course, you should be willing to learn more. Don't be in an assumption that, oh, I don't know about this, I don't want to try, right? So many students with whom I see, they come here, they're just scared of doing something new, right? You have to do something new, you have to fail, then only you will learn. That's the problem. When I say, oh, do this, so I don't know about this, right? Of course, nobody knows. When I started, I don't know anything about this, right? So you have to try, you have to be willing to learn, you have to willingly fail in many of these things so that you can learn, right? Finally, some tools, always it's good. Nowadays, we are just moving into a lot of online or coding tools. It will be helpful if you know some of it, because don't just say that like you are a civil engineer, so I don't need to learn coding. Now it's not the age. You should learn a little bit of coding, which always helps. So try to get into any online programs. You can learn. It's not very difficult to do that, right? So always, if you have these tools, if you know these tools, always be helpful, right? Right? And mostly try to learn how to interact, how to write. So this is one suggestion I will give if you want to come and do internship when you are especially writing to the faculty, right? So I'll stop here. If you have any questions, let me know. You can email me, but email me properly. Thank you. Thanks.
Thank you, sir, for the insights. Up next, we have Professor Pradeep Pradapa from Structural Engineering Department.
Just wanted to check whether it's mouse power. It doesn't work. Can you guys hear me? It's all about that. Okay. So, hello everyone. My name is Pradeep Pratap. I'm a faculty of structural engineering here at Civil Engineering IIT Madras. So, CEA has invited some of the faculty here to share our thoughts on what kind of research we do here and hopefully give you some guidance on your future career prospects. So, I have a presentation which we typically give for prospective students of structural engineering at IIT Madras. So, we'll go through what kind of research topics our faculty are involved in. Along the way, if you have any quick questions, please feel free to raise your hands, or we can also have a discussion at the end of the presentation. So what you're seeing on the first slide here is a photograph of our structural engineering laboratory. And since you're all here, you come all the way to IIT Madras, please make sure you visit the structural engineering building, which is right next to the civil engineering department building sciences block. And you can have a look at the equipment and all the machinery we have there. Right? This is one of the kind of laboratory in the country. And it was established with German collaboration in 1971. So obviously recently we also celebrated the 50-year anniversary. And you can see all the colors are in very old-fashioned green shade. So they are still the same machines which were installed 50 years ago, and they are still running. Right? We use them day in, day out for all the research and also industrial projects we carry out in the lab. Okay. So just a quick overview, we have about 17 permanent faculty. We also have professors of practice, that is people who worked in the industry, they came back to our lab to teach students and interact in a more industry-oriented fashion. We have about 15 MTech students graduating per year. These are the number of students graduating per year from our lab. 4 master's students and roughly 5 PhD students per year that are graduating from the lab. Number of alumni, I don't have an exact count, but I know for sure that it's greater than 1,000 based on a rough estimate, so I put that number there. And And the research funding also, I have no clue exactly how much it is, but it's going to be more than 5 crores per year. So broadly, in terms of research areas that we work on, these are similar to any structural engineering stream at any university across the world. So they work on concrete structures, metal structures, some special structures, for example masonry or other structures. And we work on structural mechanics, solid mechanics aspects, and also earthquake engineering. And we do this research using either theoretical studies, computational simulations, or experimental testing, fabrication, construction. So we have a huge lab, as you see. We have enough space for fabrication also as well as construction. And we are also moving into using data science, AI, ML tools towards future of structural engineering and civil engineering. So sorry, the issue with there's some font issue with the presentation, so just ignore that. So here you can have a look at all the faculty that are in our lab right now. We have senior faculty, mid-career faculty, and a lot of young faculty, including myself at the bottom there. And here on the right, you can see a color-coded keywords for all the research topics that we are working on. So for example, the ones in red shade at the top are all related to concrete topics. Shear walls, voided slabs, precast, optimization, even 3D printed concrete and so on. And in blue color you have the ones related to steel, steel concrete composites, stability and so on. And at the bottom you have composites, morphing structures, heritage structures, masonry and so on. And on the right you are looking at mechanics related topics, fracture mechanics, glass load, computational mechanics and so on. And at the bottom right you are looking at earthquake engineering related topics, including structural dynamics, non-linear analysis, hazard analysis and so on. These are, most of these words you might have already heard about, but you also might have heard, seen some new topics here which you have not heard before. So over the next few slides what we will do is I have picked selected topics which our faculty have been working on in the last few years, and we'll go a little bit deeper into what we are trying to contribute across the nation and also across the globe. So the first one is related to structural health monitoring of bridges. So our faculty are involved in, for example, the structural monitoring of the Pamban Bridge. So you are all familiar with Pamban Bridge. It's in the news recently. Why is that? So they have a new version out there, right? But the last decade we have been involved in structural health monitoring of this, one of the oldest sea bridge in India. Right? You see how the damage accumulates by the use of sensors that are installed on the bridge, and we have developed the algorithms to monitor the structural aspects of the bridge. And our faculty are also involved in restoration of heritage structures. For example, here you are looking at heritage structure in Myanmar. It's a UNESCO World Heritage Site, and we are involved in computer modeling of these structures and structural analysis, and proposing retrofit strategies for the conservation of these structures. Right? We also operate at a global scale, as you can see. Right? And here is just an animation of some industry-related projects that we work on. For example, on the left we are looking at design of cable-stayed bridges. On the right you are looking at design of high-rise buildings. So just to make it a little bit more interactive, I wanted to ask you, so what do you think is the bridge on the building on the right is doing?
Stabilizing the
Okay, let me ask the question a little differently. Do you think it's dancing? It looks like it's twisting, right? So what kind of dynamic mode is that called? You're all undergrad, I know, but just by looking at it, it's twisting. Do you know some name for it? Torsion mode. It's a torsion mode, right? So do you think it's a good thing or a bad thing? Why is it bad for buildings to oscillate in a torsion mode? Yeah, so you don't design the buildings for that kind of a mode, right? You have something called lateral resisting frames, and then you either want it to predominantly oscillate in this direction or this direction, and then you design the structure for that. Therefore, you have to make sure you design it so that this twisting mode doesn't occur first. Right? So I just wanted to throw something so that in case you're sleeping, hopefully you wake up and you start interacting. Right? Okay, so then we are also involved in development of numerical methods and computational modeling techniques. So here we are looking at ground motion simulation. So ground motion is obviously we are talking about ground, right? And which part of this earth are we simulating from the thing you are seeing here? Can you guys say it aloud? India? Right. But do I see something more than India or just India? Why is it more than India? Why don't I just simulate the ground motion in India? It's called Indian subcontinent, right? That's why it's more than India. But why is that? Why do I have to do more than India to simulate ground motions? Tectonic plate related to the Indian subcontinent is to that extent, right? So now, when I say simulation, you're going to do simulations on a computer, right? How many of you are familiar with the technique called finite element simulation, finite element analysis? You might not have done it, but have you heard about the word finite element? How many of you have heard? Raise your hand. Only 3 of you, 4 of you. Finite element analysis. You didn't see colorful models in the computer, people playing with it, and then they are doing some crazy things. That's all finite element analysis in the context of mechanics and structural engineering, right? So if you are going to do any engineering and any analysis of stresses, strains, and so on, you are essentially going to do finite element analysis, right? So when you do that, what you do, you have a structure, you discretize into small parts, right? And then it converts into matrices, and then the computer solves those equations, right? So here we are doing the similar thing. The Indian subcontinent is split into small parts, and it is converted to mathematical equations which are in terms of matrices. And now the question is, what is the size of this matrix? What do you think are the size of matrices for structures that the computers are solving? So let me give you 3 options. 100 by 100, 1 lakh by 1 lakh, 1 crore by 1 crore. 1 lakh by 1 lakh, typical numbers. Okay, fine. What about here? What do you think is the size of the matrix involved in doing simulations for something like this? All of you know matrices, right? You're all engineers here? Okay, fine. So what's the size of the matrix here? You can see some numbers there. You see something called 4 billion. How much is 4 billion? 400 crores. So you'll have a matrix of size 400 by 400 crores. 400 crores by 400 crores. How do you solve such a matrix? Do you think my desktop computer can solve it? Let's say my desktop computer takes few seconds, 5 seconds to solve a 10 lakh by 10 lakh matrix. This will be solved in all the years. So how do you think they're solving it then? Supercomputing, right? So we use parallel computing, several computers connected together. So that's where one of my colleagues is saying they have 1,000 cores, right? So it's essentially you have thousands of computers together connected, and then you split the matrix across those, and then you solve it. Right? So we are doing high performance stuff at projects of national importance, and at also fundamental scientific relevance. Right? Okay, so then anyone has seen this kind of a map before? What is it? Seismic zone map of India. Right? So it says depending on where you are in the country, how much intense earthquakes you may potentially experience. So the structures will potentially experience, therefore you will have to design the structures for that much earthquake load. Right? So you can see Chennai is in what zone? Zone 3. Right? Zone 3 and above it gets more critical for earthquake design. So who has developed this map? Of course, our own country, right? So our IIT Madras faculty played a key role in development of this map. Right? This is the latest map. Of course, the previous map was a little different. So this is part of the latest code. Which code is this? Anyone remembers the number of the code? CSP design? BTech, right? 1893. Okay, so some other example. Now we will switch gears. So here you are looking at something very interesting. Looks like a truss structure, isn't it? How many of you think that is a truss structure? It's not a truss structure. Does it look like a truss? Don't read anything on the slide. Just look at the picture and tell me what it looks like. It looks like a truss, right? But I'm going to call it a material. Would you believe me? I'm going to call it a material. It's not a truss, it's a material. So let's say this dimension is about 30 centimeters and the other dimension is about 30 centimeters. I'm going to wrap it up with a membrane and I present it to you. You say it's a truss or you think it's a material? It's a material, right? For example, look at the thing at the bottom. It's like a rubber block, right? And you call it as a material, isn't it? Rubber block is a material. You will not say it's a structure. So if I stretch a rubber block, what will happen? It expands. And in the other direction, it contracts. stretch it in one direction, it expands, it contracts in the other direction, right? And this is a thought experiment, but it's also a proven result in mechanics. If you bend that block, you can see a slight saddle surface. Okay, so you could have probably come across this in your mechanics course, but a thing that stretches and contracts in two directions, you bend into a saddle shape. Right? So now what I'm saying is I have something else which I have created using this plus kind of analogy, but I'm calling it as a material. But when I stretch and contract, similar to this rubber hit, but when I bend it, it's not bending into a saddle, bending into a dome. So that is something exotic. It's not happening in nature. But when I make it artificially, that's happening. Right? So that's why it's called a metamaterial. A metamaterial is not a natural material, an artificial material, but it is exhibiting something unique and exotic. Right? So we are involved in simulation methods, theoretical development to understand behavior of such metamaterials. Right? They will have applications in a lot of very niche engineering applications. So our faculty also work on structural fire engineering. So what's that on the left? No, fire accident is okay, but what is? Do you know the event on the left? That's what. If you are BTech now, you might be just born, I guess, or maybe not even born at this time. Yeah, not born. So those are the World Trade Center 2001. Yeah. So the temperature in these fire accidents could rise to as high as 1000 degrees centigrade. And that's the real thing, right? So if we're going to make structures, and there could be fire accidents. At 1000 degrees, what happens? Do you know the transition temperature for steel to become weak? Broadly speaking. 600, 700 degrees centigrade. So at 1000 it's not. So your structure is just going to be a soft material. So how do you deal with it? Of course you have to use protection and so on. But then you have to understand how your structure behaves as you keep increasing the temperature. Right? So how do you do the experiments and modeling for that? So you could do something like this. At the bottom you are looking at electric furnace or radiant panel techniques that are developed in our lab. So we have our faculty have been working on developing techniques to do experiments for such scenarios. And then as you can see, we have so many topics here. How many faculty are there in structures lab? Anyone remembers the number? 17. There are 17 faculty, right? So you will see a lot of directions of work. So another faculty is working on blast and impact load testing and simulation. So at the left bottom of the slide, you are looking at a setup. It's called a shock tube. Right? You have a rupture at one end, and it releases a shock wave, simulating a blast wave. And then at the other end, you have some specimens from which you can see their behavior under the action of this blast. And this can be used for development of blast mitigation devices. So on the top right of this slide, you are looking at a polyurethane foam when it's impacted by this blast wave, how it responds. And in the bottom, you are looking at concrete panels which are impacted by ballistics, bullets. And then they are conducting experiments as well as simulations. So we are working on these topics as well. So another interesting topic called origami engineering and metamaterials is something I work on. So what is origami? Anyone has heard the word before? Japanese thing, right? How many of you have not done origami till now? How many of you have done origami till now? All of us. Anybody who touched a paper and folded it, that's origami. You folded a paper, that's origami, right? Make sense? So, origami engineering is essentially folding sheets towards engineering applications. For some engineering applications, right? As you can see, just look at the pictures on this, it already gives you a sense that, yeah, I can see the potential application. The left bottom thing is straightforward, it's a space technology. You cannot transport large structures in rockets. You have to fold them and then deploy them when you go to the space, right? So it's been there for a few decades already in aerospace and other fields, right? Now the idea is, can we start using these for foldable structures, deployable structures and so on. So here at the bottom, for example, you have a video. I don't know whether I can stop playing or what? So that is actually a thermocol sheet and it's just glued through tape. This was done by my MTech student, right? And he is just folding two parts of that entire structure at one end and the whole structure lifts up. So that gives you an idea of how you can make deployable structures just by controlling the folding geometry of the connection of different panels. And that's origami. And here at the top is that same truss structure you have seen in the previous thing, which I called a material, but it's a 3D printed version. And the size of that is actually around 10 centimeter by 10 centimeter. It's all 3D printed with multiple materials in the workshop at IIT Madras. And here you are looking at something called origami metamaterial. And unfortunately, I don't know why this is not playing on. You can see this. So what did we realize when you have a rubber sheet, I stretch it, it contracts in the other direction, right? See what's happening here? You stretch it in one direction, it expands. Do you believe this? How many of you have seen this before? Where did you see it? YouTube videos, right? Do you think this is fake? Could be AI generated, right? How do you know it's true? Until you see it by yourself, right? So that's why I got so this is the Bureau model. See, you can see this one. If I stretch it in one direction, it expands in the other direction, right? Of course, that's a little bigger one. You can see there are more cells there. But interestingly, it is made from single sheet of paper. Just a thin sheet of paper. But if you fold it appropriately, then it shows this interesting behavior, right? So an origami, which is behaving as an effective material, with some very interesting property. Therefore, it's called an origami metamaterial, right? Where do you think this could be useful? Does nature exhibit negative Poisson's ratio? This is called negative Poisson's ratio or auxiliary material. Does nature exhibit negative Poisson's ratio? So you have come across the term Poisson's ratio in your courses, right? What is the typical value of Poisson's ratio for materials you study? 10, 20. Okay, let me give three options. 0.1, 10, 100. Huh? 10. Hey, it's okay to be wrong. Better to give an answer. 0.1. So typical values for engineering materials will be around 0.3, between 0 to 0.5. Okay. So this is negative. Right? So it's an exotic property, doesn't exist in nature, therefore it's called a metamaterial. So where do you think it's useful? So imagine somebody is going to impact it from one direction. Right? If you're going to impact it from one direction, the other side also comes together and offers a resistance. So it can have application in impact resistance, right? Impact mitigation. Where do we have impact? Is impact resistance useful? Can you give me an example where we will have impact? Huh? Buildings. What is going to impact my building? I need to. It's a one-time thing anyway, right? Regular impacts. Where do I see regular impacts? Metro. Helmets. Right? Cars hitting highway guardrails. Right? So you have so many places. Impact is a common thing. It's happening every day, everywhere. Right? Okay. Okay. Now we move on to experiments. As you can see, our lab is, it's a huge space. Lot of equipment there, lot of machinery there. So it's primarily driven by experiments. Right? Science has always been driven by experiments. So what kind of experiments do we do in our lab? We do, again, projects of national importance. What are you looking at here? Tunnel for a metro rail, right? CMRL. CMRL is Chennai Metro Rail. So we are doing the testing for panels for those tunnels, right? So what kind of stresses will be there in those panels? Anyone? How many of you know what is stress? How many of you don't know what is stress? So everybody knows what is stress. Is it compression, tension, something else, shear? What kind of stresses will be there in the panels? Shear? Yes, sir. Shear? Why? It bends. Okay. Have you heard about arches? Yes, sir. Arches are in compression or tension or something else? Okay, think about it. They will all be in compression. Tunnel is like an arch, right? If you have an arch, basically everything is going to be in compression. Okay. But then when you're going to install them, you're going to lift them, you're going to move them around and so on. So they will also be subjected to other kind of bending and shear and other kind of. So we do all kinds of tests. This is like a bending machine in our lab, and behind you are seeing the compression machine. So we have tested these panels for different actions. What is this? Concrete 3D printing. Right? On the left you are looking at a video, and on the right is where we have tested these concrete 3D printed walls in our lab, and we have proposed some improvements for the design. Right? So this is the cutting edge technology that is coming up, faster technology, enhanced design space. You don't have to restrict to straight walls, straight structures, and so on. You can go with crazy shapes. Right? So future is being built here. Then, as we, again I repeat, we have a large lab space, so we can potentially test large structures. So a full-scale slab. What do you think is the size of the slab there? It's mentioned on the slide, by the way. It's not an example. 3 to 4 meters, right? Is that a typical large-scale slab? 3 meter by 4 meter is a typical room. 10 feet by 12 feet, right? So you are testing a real-size slab there, right, in the lab. Then here is one experimental test on reinforced concrete beams, optimized reinforced concrete beams. See, when you take a reinforced concrete beam, right, is concrete good in tension or compression? Tension. Concrete is good in tension or compression? Compression. How many of it say tension? How many of it say compression? Okay. How many of you know what is a beam? Is there tension in the beam or compression in the beam? Both. Is concrete everywhere in the beam? Is there concrete everywhere in the beam? So there is concrete even where there is tension. Does it make sense? Concrete is bad in tension, right? Why am I placing concrete in tension? We don't have a better way to manufacture the beam. The bottom of the beam is in tension, the top of the beam is in compression when I bend it. Right? Top goes together, bottom expands. But I have concrete at the bottom of the beam and it's in tension. Ideally I don't need concrete in tension. I just put steel there. Steel is going to get corroded or it may not get integrated with the concrete. So you have to put concrete everywhere and there's no better way to make than just put a rectangle there in the cross section. Right? But now we saw 3D printing and some advanced techniques are coming up. Maybe I can do crazy shapes. I don't have to restrict to my cuboidal beams, right? So with that idea in mind, we started doing some theory. We did some slightly crazy shape here, and we saw that you can remove almost 40 to 50% of concrete in your beam, and you can still get same strength, same deflection, same everything, same shear, pressure, everything, right? So that's what is this experiment. Then our faculty are also involved in design of landmark projects. This is a memorial structure on the Marina Beach here. If you have some time, you can go by in the evening and check it out. Right? Our faculty have designed that and some bridges and so on. Right? So with that we are almost ending. So of course we have had great history of being part of development of Indian standards for structural design. As you can see, some of them are mentioned here. Collaborate with faculty across several countries. The list is not exhaustive here, but I think we captured most of the places. And then this is where our alumni are going out to, masters as well as PhD students. Most master students obviously go to the industry, right? You can see the kind of companies they are going into, and PhD students also go to industry, and some of them would prefer to go into academic jobs. Like for example, they have become faculties at other IITs and NITs. Some of them went abroad for postdoc opportunities and so on. Master students, some of them go for a master's PhD abroad as well. Right? And then we have a lot of interesting activities for our students. We have something called Structures Research Forum, where all the graduate students get together and celebrate several events related to our department and as well as our division. We have site visits to ISRO or shipyards or Navy yards and so on. So this is a slide we put in this so that in case you are not aware of the fellowship opportunities that are available, if you want to come and pursue higher studies, for example, either a master's program or a PhD program at IIT Madras, there are a lot of fellowship opportunities which can be used to fund your education here and also research. Right? So I don't want to go through all of them, but just be aware that if you are excited with all the things we have discussed in this presentation and you want to come and talk to us, there are funding opportunities. If you have a good profile, you are strongly motivated, committed to doing world-class research from IIT Madras, there are opportunities to support you. Okay. So that's conclusion. So this is a photo from our current lectures group. Students help us in a lot of events here. So that's more of their leadership development, which is very important. So they're not just sitting there in their desks and doing research or writing code or something. They're actually running the lab 50% of the time. Right? So thank you for your time, and we welcome any sort of discussion or questions. Done.
Thank you, sir, for the insightful talk.
So you need a mouse here.
Up next, we have Professor Nikhil Bugalia, sir, from Building Technologies and Construction Management.
Yeah, my job becomes very easy because a lot of the common things have already been covered by colleagues. So yes, a slight correction in the name. We are no longer called BTCM. We are BTCM 2.0 in a way. So our full form now stands for Building Technology, Construction Materials and Construction Management. Right? So there is an explicit focus on construction materials also, which is slightly distinct from the structural engineering. Traditionally, if you see in most of the education institutes in India, a lot of work on construction materials as well as the structural side happens together. But in IIT Madras, they are two distinct groups, and there is a reason for that. And it's not that we don't like each other. We like each other very well. We work together very well. But it's about having a specialized focus on construction materials because the today's research and today's world demands are there, right? And I'm going to explain that a little bit. But essentially what happens is these are so much broad areas, and therefore we have also organized ourselves into solving a bigger purpose and a bigger problem so that there is a coherent alignment of all the 15, 14 people that we are there. We have also borrowed some faculty members from different other groups. So what I'm going to present today is a special center of excellence that we call. We have something called Center of Excellence on Low Carbon and Lean Construction, Technologies for Low Carbon and Lean Construction, or commonly known as TLC2. Right? So a majority of faculty members in TLC2 are also the BTCM 2.0 part of it. And in case you are interested in allied area, especially you have to look for BTCM and Civil Engineering website in order to solve this. Right? I still need that mouse. Yeah. So,
Go back.
but now it's not going
No,
back.
you just stop it. Stop it.
Slowly it's going back. Okay. Alright, let me start. So, essentially, I'm not sure, are you guys familiar with Sustainable Development Goals? Have you guys heard about them, read about them a little bit? So yes, Sustainable Development Goals is what we collectively decided, the world decided that these are the goals by 2030 that the world needs to achieve in order to make the world sustainable for the future generations to come. And there are 17 goals, including the Partnership for Goals and so on and so on. These are very high-level goals, of course, across the world. World leaders came up and developed these goals, and there are a lot of individual indicators. And our group basically focuses on some of these ones that are highlighted, which is essentially related to the infrastructure, sustainable community, climate action, particularly about what we talk about the sustainability in terms of the carbon emissions, right? So have you guys heard of the word carbon emissions before, CO2 emissions? Why are we worried about CO2 emissions? Are we worried about CO2 emissions? Why are we worried about CO2 emissions? Global warming potential of these gases because they take long term and they entrap the heat, and the heat then has a lot of impact on the weather patterns, and it affects everyone, right? And I think I will not exaggerate, but I think we are also reflecting slowly. March and April are becoming hotter and hotter. So there are global shifts observed in the weather patterns, and India is definitely one of the countries which is receiving a lot of challenges related to this. And if you see the global CO2 emissions, you will realize that 11% of world's CO2 actually comes from buildings. And a large contributor of that is the culprit material we call concrete. But the concrete, could you actually construct without concrete? You can, but the world is actually has lots of concrete, so much that I think there is some stats that we consume more concrete per day compared to the water on our in terms of the drinkable water that we consume. So that's the amount of construction that we are doing as a world, right? And therefore concrete as a material, since it has such a huge quantity, making that sustainable, making that less carbon intensive becomes one of the major focus for us, right? So that is the basic. Yeah. So that is the basic premise under which we are working. But as you can easily imagine that yes, there is one aspect of it, the material, but then if you think only about the materials, you will not be able to solve the problem, because how the material gets used throughout the entire service life of a structure becomes extremely important. So if you see, we call this circular economy concept, where you start thinking about whether there could be new materials which are less carbon intensive. New materials could also be from the way made of from recycling material or waste material, and how to use them in the concrete. But then we also, of course, making waste new material, we have to deal with certain material related properties. For example, in cement or concrete, what are the kind of material property example? Do you know? Any material property example of cement? Any tests that you remember that you have done for cements? Sorry? Any cement related test that you have done? Compressive strength is a cement related test? Soundness test? Consistency test, right? So these are properties of the material, right? We try to assess. Compressive strength is also, but that is within the realm of mechanical properties. But the material offers a lot more different things. Some of these are related to the density of it, the soundness of it, what is the surface density, and many parameters. So of course we characterize them, but then ultimately we have to construct using them. So characterization of mechanical property becomes an important aspect. Just because a material is strong enough does not mean its design is automatic. As Professor Pradeep was talking about the beam structure example, that we are actually using a lot more concrete than you actually need. So could you actually come up with better and different ways to design the structure given a material property? And as the material changes, the way to design will also change. So we consider that. Then of course we have to talk about the construction process. We are not only related to designing. We, as a construction management group, one of our larger focus is actually to get things implemented on site. And that is where things become tricky. Unfortunately, despite being like such an amazing country in terms of produce and becoming an important institute where we have lots of faculty members working on interesting research areas, you can also see that Chennai is not doing, or any city for that matter, I'm not wanting to name anything, we do have general problems that our roads are still not good, our bridges are still not good, there's so many damages that we observe. So there is a lot that happens between lab scale research to actually getting it constructed with a good quality on site. And that is where the construction technology or understanding of construction processes related work come. A lot of this is actually not even related to technical capacity. It's actually related to a lot of management topics, for example, financials, understanding contracts, understanding the quality issues, understanding the safety issues. And these are all the topics that we actually deal with. And once the structure has reached to its end of service life, then we also talk about demolishing it, how to properly demolish so that it can be brought back, recycled, and then reused into the next set of materials. Right? So we actually work in this whole cycle. And I don't know how do you manage it. Can you please help me there? Yeah, just click on the next button. Yeah. So one of the main arguments that we try to make, especially in order to make the concrete sustainable or the construction environment sustainable, is of course having a focus on recyclable materials. So one of the examples is the demolition waste that comes out, and we actually try to recycle and use it again in the concrete. Or a lot of our colleagues actually work on fly ash, that material. We have all know fly ash has good properties, it helps. Also these days there's a lot of agriculture waste that goes otherwise into burning and creates a lot of issue. You can actually use that in concrete. So all that kind of research we do. But actually what you don't realize on construction sites is there's a lot of process waste. How many of you seen construction site? Have you been to construction site? How many of you seen that on a construction site you will find 5 people doing nothing? Is that a waste? Yes or no? Why is it a waste? Why is it a waste? They are not being productive, right? So that is the kind of definition of waste that we adopt. That it's not only about the material waste in terms of how much ton of extra material is getting produced or not. We actually talk about process waste. And when we talk about process waste, we actually go to the depth to identify, do we need to transport this material in such a manner from here to here? Are we actually losing time in order to do this particular activity in such a manner? Why are the people standing there doing nothing? Why are we losing resources on them? Why are we losing money, time, human resources? These are the kind of concepts that we deal with. So, and when you together combine them with the material research, material design, construction sequences, processes, all of this actually helps you understanding of this kind of a process waste. Pretty cool. Yeah, and in terms of, so these are main idea in terms of achieving the sustainable construction, but the kind of activities that we do, so one is of course the core part of it which is related to developing the technology and leading research in this particular area, but we actually do a lot more work with the industry because construction management and any work, if does not translate to the real industry, it's not really helpful, we are not creating an impact. So that is where we partner with industry to implement some of our work, and I'll show you some examples. We actually provide industry with a large scale facility so that they could come up and with ideas and test and come test with us. We actually work with a lot of startups in order to disseminate and create new knowledge and new innovations. And some of those things is what I'm going to show you one by one. Can you go ahead? So some of the projects, this is the work that my student is currently doing. You might have seen lots of garbage on the streets. No matter which city are you from, it's a common sight in everywhere in India. So one of my students is actually working a mobile app where you could just go scan around the waste. It will be able to tell you how much quantity of waste, what is the type of waste, and that kind of an information is extremely helpful for people to optimize the collection of this waste, because if the waste is mixed, it's not segregated, its recycling potential also goes down. So we can actually tell you that information very well in advance, that you just go take a mobile phone, scan it out, and it will give you an idea, okay, this is the kind of composition, so perhaps you can take it to a certain location in a particular area in the city. Right? So those kind of solutions. We also work on robotic applications. So this is a robot that Professor Benny, who is currently serving as the head of the department, his students have developed with. It is a robot that can segregate the demolition waste that comes into recycling plants. You can see this is the kind of waste that you typically get, and there are actually humans which are trying to, this waste actually goes onto a conveyor belt, and there are real people trying to segregate. So such kind of robotic applications we are trying to develop. Developing this is extremely hard. It looks a very simple, elegant process here, but for a robot to know where exactly to pick up the waste is a very challenging problem, because you are dealing with uneven shapes, uneven weight, so estimating which exactly is the centroid point of this particular material that you are trying to pick up, how do you pick up, how do you grip it, these are all very interesting challenges that we actually deal with. Can you go next? This is a material in terms of recycling the C&D waste. Typically you would rely on a lot of chemicals. What is the biggest problem? Have you guys heard of, have you seen recycled aggregate or after demolition aggregate that gets generated after demolition? Many of you might have seen, but typically there is a lot of powder attached to it, and that is the powder which is the mortar of the cement, right? So that is actually very weak. If you start using that directly into new concrete, it becomes very, very weak. So you need to remove that in order to use the aggregates again. And that's where the current methods that existed were actually related to chemical related processing. You put them in an acid bath and it just goes away, and then you can use the aggregates again. But our colleagues here actually demonstrated that you don't need to use these harmful chemicals. You just heat it up to 500 degrees, keep it for 1 hour, and then you just shake. Aggregate is as good as new. Like it's literally as good as new. And they actually demonstrated that using solar energy, you can reach the 500-degree temperature in a concentrated environment. And they tested it in this is a Mount Abu solar farm in Mount Abu, where these kind of concave mirrors are there, which can concentrate the solar power in a dolly, and you are able to achieve aggregates which are as good as new, and the properties are really, really nice. So idea is that this started with a very lab scale idea, but we have actually demonstrated the potential of it working in a really large scale project. Now those people are happy because earlier they were wasting that solar energy that was getting concentrated. Now they can actually use it to recycle some of these aggregates and locally in Mount Abu region they are constructing a lot, and some of these waste materials could be directly used there. There's a lot more focus in our research group about finding alternative raw materials. Cement being one of the major raw material becomes a headache in order to, and of course it's very difficult to reduce to a certain, the carbon potential to a certain extent. So talking about limestones, talking about biomass and these kind of things are there that we have worked extensively on. Can you go ahead? We do have our own cement manufacturing plant, so you don't need to actually rely on somebody else to produce a cement. If you think you have a new waste material you want to try, we can actually make cements for you. So we have a small scale kiln where you can actually make your own cement and then do the experiments on. Do you want to make your own cement? I perhaps don't want to, but I'm good to see the excitement in the people here. Go ahead. And then, yeah, these are some of the real life structures that we have created. I'm not sure if you recognize the person here is Professor Manu Sultanam, who is currently in charge of this whole building. And these are the structures that we created, which are made out of this LC3 material and the biomass related material, which is a very sustainable material. And this actually useful for coastal areas where you can reduce the soil erosion problem if you try to put. And these are purely concrete, so large quantity of concrete, but you don't need so much structural performance. So actually it's a very high material that is otherwise going. So if you can make those materials more sustainable, these are the high volume applications of concrete. So it helps a lot in reducing the carbon potential of these things. Then of course, this technology that you also saw, the panels were being tested. So while we also have our own smaller set of machines, this was for Patna Metro, where we actually, some of the technology that we had developed, we tested it out and we actually developed patent, and that patent has been now transferred for Ultratech also in terms of producing an FRC and the grout that we are trying to do. Grout, typically when you do the pre-stressing applications, you need to fill the tendons with the grout so that the corrosion properties are improved. All those things related work we also do. Go ahead. One of our major focus is to now promote the precast construction. Professor Pradeep also shows some of these 3D printed technology and the structural performance in them. We do believe that moving forward, we need to move away from the conventional way of constructing. We need to explore these. And this is actually the video of a sports complex that was built in IIT Madras campus. And you can see that all of this was a precast column. You can see the column and beam joints were actually getting prepared almost automatically, but this was using cranes and lifting things. So a lot of interesting learnings. Whatever we learned in the lab through the simulations, we have actually been able to implement some of these things in our own sites. That is, and again, the beauty of IIT Madras, at least there's so much construction happening within campus that you can try it out, you can test it out, you can actually see your work getting impacted. And then you have much more confidence to show somebody else that, hey, we have actually done this, you can also do it. So currently we are actually taking it one step further, where we are prefabricated and pre-fitted. So in this case, there's only column and beams coming up, but there is a technology called PPVC, where you have everything fitted. Your room is almost ready. You just pick the room and put it on the site. And that is something that we are experimenting with right now. The new 2 hostels that are going to be constructed in IIT Madras is going to be using that technology. The tender process is on way, and that is something that our group is also contributing extensively. Can you go ahead? Yeah, this is of course, as Professor Pradeep was also mentioning, anything in civil engineering requires standardization if you want to have a large-scale adoption. Otherwise, one-off application people will not, because if everyone in the country wants to, they need some guidelines, and guidelines are in the form of standards and regulations. So those kind of things also we are contributing a lot. Can you move next? This is a interdisciplinary kind of project that was taken where to realize concrete requires water. Concrete is quite water hungry in that way. And could we actually use the wastewater that is coming out of our wastewater treatment plants to actually make concretes. This is quite interesting problem, but if we are able to solve this, it will solve two problems in one shot, right? And the biggest challenge that you have right now, I think the basic requirement in concrete is that water has to be potable water. And this is where we are trying to challenge the norm, know that you don't need potable water, you could still achieve the properties, even if whatever is the given level of concentration of the pollutants even in the wastewater. So the different degree of treatment you can achieve. And if we are able to achieve this, it actually solves a lot of purpose, because it's very hard for wastewater treatment plants to also achieve the potable water requirement. If we can directly use that effluent into concrete application, it can create a lot of interesting applications for concrete manufacturing within local environments. You don't need to go large scale city. Even a village could perhaps start manufacturing their own concrete. So these are some of the work that is ongoing, working closely with colleagues from water resources and management. I'll just move this, yeah. Then there are lots of research topics related to the construction management, and particularly this is the area that I work on, is actually developing virtual reality. Have you guys seen VR headsets? So VR, they are quite interesting. I particularly find them very interesting. VR games are very amazing, by the way, they are very immersive. But the same idea, the immersiveness, when you feel so connected with the environment, could you actually use this to teach people, right? Particularly I work in the area of construction safety. And if I want to teach people safety, it's not ethical for me to push them in an accident in order to make them learn. So at least in VR, I can make them experience those things. How does it feel to be in an accident scenario? And that could help them learn better and avoid some of these things. So that is where we are experimenting a lot with how to use this virtual reality based technologies to scale up the skill development effort. Just to give you numbers, in India, right now we are dealing with about 56 million workers which are poorly skilled in Indian construction industry. So the scale of problem that you need to address is huge, and this is one of the biggest problems that industry faces, that they are not able to find skilled workers to execute some of these tasks that they need to do at construction sites. Professor Pradeep showed actually the 3D printing related properties. So he actually showed you the result of a compressive testing result, I think, on that kind of a machine. Here we are taking, using purely a camera, we are able to predict whether this kind of a as you print the material, is it going to be stable or not. It's purely from camera. You don't need to do any testing. I'm not saying that testing need not be done. Testing still needs to be done. This is a fresh property kind of an idea, right? As you are printing the concrete, you are able to predict whether this particular element is going to survive or not. And if not, you can actually control the rate at which you are printing, or at which maybe you can allow the concrete material to get more hardened before you put the next set of layers. So it's purely a vision problem. Purely looking through the camera, we are able to tell when is this particular layer going to fall or not going to fall. So this is, of course, there's a lot more automation and the computer vision, coupled with more modern AI techniques, actually goes into this kind of a research. This is a work again that I am involved in, particularly on construction workers' safety side. So those who are following IPL, I think you will should see these kind of graphics a lot more these days, where you can analyze the angle at which the bowler is throwing or where the batsman is actually making the shot. But you can apply the same thing to actually analyze if the construction workers are safe or not, or are they actually exerting a lot while working. Because you can estimate how much fatigue they are going to generate, you can estimate how much are they going to develop an injury, are they doing too much hard work, and so on and so forth. So these kind of, again, purely using computer vision and algorithms. So you take images, and based on that you are able to generate a risk profile of a particular construction worker. This is again done by my student. She is not my student. The image is taken from a faculty, a friend from the US, because the image was clean. In Indian images, it's become very difficult to just show this particular case. So yeah, she is not my student. Go ahead. Then, as I was telling you about that, in construction management, we are not only dealing with just designing things in the lab, but ultimately everything has to be constructed on site. And a lot of this actually relates to contracts. What is written in the contract actually gets happened. But contracts are these boring documents. Have you ever read the contract documents? And ever? Anyone? Any legal document? UPSC aspirants? No one is UPSC aspirant here. If you just read legal documents, I cannot survive beyond a page. It's just too tough for me to read. Fortunately for us, we have a colleague in our department who just loves to read these contractual documents. He thrives on finding interesting clauses in them. What are the because this is a large document, nobody reads it. That's the problem, that nobody wants to read it. It's similar to when you download a new app and they say sign this agreement before you proceed ahead. What do we do? We just scroll all the way down and we accept, right? We are giving all the rights to our data. We are giving all the rights to use all images, whatever, access to phone contacts, everything. All apps require that typically, but we are straightforward giving that. But because nobody has time to read that boring language, but fortunately, one of our colleagues is actually very excited about this. So he develops these automatic tools, again using large language model based tools. Could you actually find out if there are some contractual terms which are contradictory to each other? That in 1000 pages, on page 240 it says this, but on page 840 it says this. So in case there is a conflict later, what will be the good thing? Because actually people who are drafting contract, they also don't read it. They just copy paste from some other place and put it there. So it becomes very challenging once you actually go into the litigation part of it. So he's actually developed a lot of interesting analytics based on using large language model to analyze these contractual risks, and he's developing a lot of interesting task tools over there. I think some of you have also been working, those who are our students. Please go ahead. Another problem in construction sites is payment, right? Anyone has any idea on an average how frequently do construction companies pay to the contractors? Any idea? No idea on construction sites? How frequently do you get paid? After work. Oh, so if the construction is going for 5 years, for 5 years you don't get paid. No, that's very scary. No, even in government works, no. Typically there are always incremental payment conditions. Basically what you do is you ask the client that we have done so much percentage of work, you come and check, and at least the client pays you for that much money. It's very difficult for a construction company to survive for entire duration of the project without getting paid. Right? Imagine a 100 crore project, you are not getting paid intermediate. Your 100 crore is stuck in that project till the time government decides to pay you. Right? So essentially what I'm coming through is monitoring the progress as the construction happens is a very, very important challenge because directly related to payment. Also, people are interested to know whether how fast am I going correctly or not, do I need to speed up my work, where am I lagging, where am I not lagging, and things like that. And this requires a lot of effort, manual effort, and this is where some of our work. Can you click on this image again? This middle video perhaps. Yeah, so this is essentially using an iPad, you scan the site and they are able to detect what is the status of number of columns, how many columns are constructed, whether the roof is existing or not, and as you progress it, as the construction grows up, you can actually determine at what time, what kind of progress was made, right? So this becomes a very visual way of analyzing, and this is where some of our colleagues are now working in this particular area as well. Yeah, we can go ahead. So this is, I'm not sure if you guys have heard the term LCA, life cycle assessments. So I was talking about carbon emissions, right? So carbon emissions occur throughout the life of a structure. During design stage, during material stage, there is a raw material, but then there's a transportation related emissions, and then once you have constructed during operations also, there are a lot of carbon emissions. So it becomes very, very tricky. As Professor Pradeep was also explaining, if you increase the material strength, maybe you can make the section smaller, right? So does it overall reduce the consumption of cement or not? These kind of things become very, very challenging, and you need practical tools for people to make these judgments and very, very fast. So this is a kind of work that our colleagues have done, where they have actually measured the carbon potential entire supply chain, tracing the entire concrete manufacturing process, cement manufacturing process also. And they have developed, okay, for this kind of a concrete applications, these are the kind of concrete mixes or the cement mixes that you could use in order to minimize your carbon potential. So you can select materials very, very fast, and those are the kind of work that has been also done. So on this particular model, if you see, if you choose the materials towards the left bottom corner, then those are more sustainable materials, but they are still able to achieve the same desired property that you want to have. So this helps the practitioners on site to select the material very, very quickly. Yeah. And yeah, some of the work that we have done directly translates. We are not limited only to the lab scale. Ram Mandir, people know Ram Mandir? Do people know the IIT Madras contribution to Ram Mandir? I think there's a lot of interesting documentaries out there which defines, there are lots of colleagues that have been involved, but we have been involved particularly in designing the foundation for 1,000-year period for this Ayodhya Ram Mandir temple. How did you think we designed this? In order to achieve 1,000 year, what do we have to do? Any idea? Any idea? How do you design a concrete? What is the weakest link in concrete when we talk about number of years? What is the biggest problem of concrete lasting for 100 years or 200 years? Huh? Fractures, okay. Cracks, okay. But what is the problem of cracks? Because of crack, what happens? Steel. Actually, the corrosion is bigger problem. Concrete, nothing happens to concrete. So we actually got rid of the steel itself. It's basically without steel, roller compacted concrete, which is a very different, completely different type of mixed design. Of course, since you don't have steel, how do you design materials with that brittle? Of course, it presents a lot of interesting design challenges, but we have been able to achieve that, and hopefully this will work for 1,000 years. If you are still alive, please do check and let us know if this is working or not. Right? Some of this work in the Kollam, Kerala stage, we have been actually able to define durability property of concrete in the specifications, and if you see the total bridge, it has 3 spans, but the middle span actually has been developed based on the specifications that we wrote rather than what traditionally designers follow. And the Rashtrapati Bhavan project, of course, Professor Arun was also involved in this. These are very old structure, heritage structure, designing, rehabilitating them is often a very much material problem rather than the structure problem, because these are very different materials, they are not used of concrete. If you just put concrete over there, it will actually not work. So you need to understand a lot more interesting details, and that's what we have been working. In terms of 3D printing technology, again at IIT Madras, we are currently constructing a guest house, new guest house. It looks amazing from inside. The space is very, very interesting. And these are actually a startup by IIT Madras called Twasta Manufacturing. So this is manufactured by them. And yeah, they were actually a student like some of you. Unfortunately, the CEOs and the CTOs are not from civil engineering, they are from mechanical engineering, but of IIT Madras. But of course, in the founding team, there were a lot of civil engineering people, because they started as a printer company, later came the mixed design and everything, so that was their business model. But they're doing very, very well, and they're doing interesting things. So while Professor Pradeep was showing you L&T's own, we are actually able to compete with L&T in terms of developing our own manufacturing of 3D manufacturing capability and doing a lot of interesting projects there. By the way, even in that L&T project, we were also involved. So it's not that we are competing or we are promoting one. As IIT Madras, that's not the job. Idea is to promote as many as people are coming up with new interesting innovation, technical innovation. So if you have idea, we can also help you with that as well. There's no problem. These are some of our industry collaborators. I'm not going to the detail, but you will see all the range, all the big companies to all the emerging and startup companies, you will find them there. So that's an interesting range of people that we work with. In terms of global collaborations, I think every department within IIT Madras, within civil engineering, every group is very well connected. So that goes regardless. Can you go ahead? These are the startups that we have supported them in some or the other form in their journey. Majority of them focus at solving this low carbon related challenge that we have. So if you have some interesting ideas, if you are interested in this space of leveraging, changing the material specific work and how it affects the entire construction process, we could be of really good help, and we invite you to partner with us. Go ahead. Yeah, let's just close it. So this is where I will. I hope that was these are some of the plans. So right now we are out of space within IIT Madras campus. So essentially we are trying to develop large-scale facilities in our Thayur campus, which is a satellite campus where large-scale facilities are coming up. So that is just the plan for us. I'm sure you don't have money to support us at the moment, but that's not the worry. If you are interested, excited about this, maybe some of you could get an opportunity to work in the Thayur campus labs that we are going to come after, right? So yeah, this is just an overview. I think I was also asked to touch base upon a little bit of my own research journey and how do you associate with IIT Madras. I think that part has already been taken care. I 100% agree what Ramesh told you about how to write emails. So if you want more information, please write the email properly and then only you will get the information. That part is 100% true. But I just want to reflect a little bit on my own journey and hopefully that helps you. So I graduated BTech Civil Engineering in 2013 and like most civil engineers, I ended up doing a data analytics job right after my civil engineering BTech. I think that's a trend. Everyone, at that time data analytics was just coming up, so I also ended up having a nice job. Before that, my internship was actually in a civil engineering firm called Vakil Mehta Seth Consultants. They are high-rise building designers and I had a fantastic time in terms of learning, but really bad time in terms of organizations trying to manage me in how I was being productive, right? So there was a person who would come and at 6 o'clock he would turn off all the AC and he would say that now you go home, you guys are not being productive. So these kind of things, of course, hurt me or my ego at that time that, hey, how am I not treated good when I'm contributing so much to this company? And those are the kind of motivations I decided, okay, no, civil engineering is not, this kind of work ethic is something that I don't want to work with, and I ended up going into data science. Data science was working nice. It's, of course, a corporate culture. The company that I work with is called Fractal Analytics. It's an amazing company. I still endorse that company because of the really amazing work culture that they have in terms of the foundation that they have about how do they treat their employees. But again, corporate culture, it is exciting, it's good parties, it's good bonding, everything is good, but you do lack that feeling of achievement. That's something that you want to do challenging. Life becomes very mundane, at least it happened with me. And that's where I decided to take opportunities to study further. And I came back into civil engineering, went into University of Tokyo, did my master's. And in my master's, I was breaking a lot of concrete structures, long beams and testing them. And I realized that I would be very, very terrible at designing structures because it was not exciting to me at all. But the kind of courses that I was offered in terms of construction management, infrastructure management, that kind of piqued my interest. That civil engineers can do much more broader jobs. And you'll be surprised, in Japan, actually civil engineers are the highest paid jobs, which is so different coming from India, where nobody treats civil engineering jobs as like a high paid job. But it's a very well respected profession there, and that kind of excited me to pursue PhD in this infrastructure management area. And yeah, since then I am here now at IIT Madras, been about 5 years. So one biggest learning that I would say is at least constantly find for yourself what excites you, right? There are no predefined paths on how you should go. My father resisted when I changed jobs from, like, when I did not want to go for civil engineering, because he is a civil engineer and I did my BTech in civil engineering, so I was like, what is the point, you are leaving civil engineering? He also resisted my decision when I actually wanted to go to Japan, because at that time I was earning really well and he was like, why do you want to leave a job which is giving you so much money? He also resisted when I wanted to come back to India. He's like, why do you want to leave Japan and come back to India? So all of these things, see, what you are going through is very different compared to what your parents have gone through in terms of decision making. And while we respect that, we should learn from their experiences, but that should not be the only defining criteria, right? For me, it has been about trying things out and understanding from my own experience, these are the things that are exciting, not exciting for me. That's how I decided not to do a job in Japan, because working in fractal analytics, the kind of amazing work culture, I was very clear that I'm not going to survive in the Japanese construction work industry. They pay very well, but they have its own philosophy of how the working hours and long working hours, and 80 hours is nothing for them. 80 hours is like normal on top of that you are supposed to do. So I was very clear in my mind that this is not a job that I want to do, and that helped me shape a lot of decisions in my life. Okay, since you don't want to go on a certain path, you don't even make an effort on that, and you focus on all your efforts on somewhere that you want to achieve, right? So, but this comes from experience. No teacher can tell you this, so that's why at early stage, my suggestion to you is try out things. And some of the ideas to try out is maybe do a small project on a certain project, like a certain area. You just come for 6 months, you spend time, you understand what is research, you don't like it, whatever. At least make those decisions quickly in your life and move to the area that where you think you can make a good contribution, right? And second thing that I'm very strong believer of is, computer science engineer will not be able to solve the problem of making good roads. Civil engineers can solve the problem of making good roads, perhaps by using some knowledge from computer science, right? So yes, while computer science could be very attractive in the short term, I do believe that there's a lot of interesting work happening right now where you can combine your core knowledge plus your interest in computer science to genuinely make interesting things which will definitely be helpful. And this is where I would encourage all of you to at least interact with some of the startups that are coming in civil engineering domain, some of the tech dominated startups that are coming in civil engineering domain, because you will find that this is so exciting space where you can actually combine your knowledge from so many areas and develop something very, very interesting, right? Research as changing its nature, it's not only about doing a PhD, publishing papers, publishing patents, or finding an academic position. India needs a lot of people who could innovate in a different contributions. For example, being a founder, having a really good company which can support a lot of interesting projects or technically complex projects, and all of that are on the horizon, right? So do explore, and definitely IIT Madras will definitely be a place for you to at least explore these things. There are lots of faculty members who are involved either in patenting side, directly working with startup, mentoring them everyday basis, developing their technology, core technology, or if you want a more conventional, just a research, lab-based, that kind of exposure, simulation, everything will be available here. So I hope this session at least gives you an opportunity to think about it and approach any of us, right? But do approach with a proper email, that is for sure by default given. Do not show not a proper interest, right? You should at least write to somebody that, okay, I have done, and this is what my thought process is, right? It's not about being right or wrong, but projecting that this is what I have understood, this is what I want to try. You could be completely wrong about what you want to try, but that's not what matters. What matters is that you can think and you can project your ideas to a certain extent, right? So that's my take on this. I will rest here. If there are questions, we can take otherwise. Thank you so much.
Thank you, sir, for the insights. Thank you all for joining us today. We are honored to have had 4 distinguished professors here with us today. As a token of appreciation, we'd now like to present mementos to them. I invite Sharanya and Kuldeep to come onto the stage to present the mementos. I invite Professor Atul Narayan and Professor Pradeep Pratapa to come onto the stage. I now invite Professor Ramesh Kannan sir and Professor Nikhil Galaya sir to come on the stage. Thank you everyone for attending this session. I hope you have had a great evening. Thank you.